is I've got a document that runs or doesn't run on my machine, and I want to send it and all its dependencies in a way that's reproducible to somebody else so that they can run it, or if it doesn't run on my machine, to find out why it doesn't run. So Don Knuth famously wrote TeX to give the same results across space and time and across all machines and architectures, and he's done a pretty good job. And what that means is that the same inputs always give the same outputs. And part of the challenge of building on that achievement of Don Knuth with TeX is to ensure that you get the same inputs. And there's lots of parts to that, but one of them is just transferring files as required. So the situation I have in mind is I've got a small document and I run it on TeX Live, and I want to send it to somebody else so that they can run it and expect to get the same results. Now, TeX Live is big, so it would be nice if I could say these are the files that it depends on, and these are exactly the versions of the files that it depends on, and this is exactly how they should be arranged. So I've given you the information you need to reproduce the environment, off you go. Now, even when we've done that, they've got to obtain the particular versions required. And the easy way to do that is what is traditionally done with TeX Live and other distributions, is make sure they're already available. So the picture is that we look at our machine and say, these are the files you will need. And for each of those files, we'll give a secure hash, a sort of security code. And they say, here are the security codes you need. And I expect that you'll be able to get them from such and such a place, if you don't already have them. And the whole game is to ensure that 95% or so of the stuff that I depend upon, my volume, is already present on the other person's machine. And then it's just a question of identifying that stuff and letting the other person get it from their machine. So we don't have to transfer everything. We just say, here are the names, so to speak, the keys to get most of what you need. And the stuff that I know you don't have, I will send you. But I won't send you anything that you should already have. So that's one picture of it. Another picture, which I hope will be of particular interest for Nelson, is bibliography records. So typically we have a file with hundreds and hundreds and hundreds of bibliography records. Well, I'm thinking, why don't we store each bibliographic record as a separate item? And then you could say, here's the list of the bibliographic records I need, rather than saying, here's this big list, and you'll find what you need in them. So that means that you could have a database somewhere on your machine or on your network of 100,000 bibliographic records. And simply by giving the right keys, the right ones are picked out. So before I move on to demonstrating the software that I've written and the tools that I'm using, are there any questions either about the technology or about the usage or purpose or anything else like that? I like questions.
Can you explain about the bibliography you said? Well, I didn't quite get. You're saying rather than having a list, you have a separate file for each bibliography.
Okay, so what I'm thinking of is this, that my understanding is that typically bibliography files consist of a large number of small pieces of information. Mm-hmm. And you have to sort of download the bibliography files and get them into the right place in order to be able to use them. Whereas if each item in the bibliography file, when I say the bibliography file, it's a collection of BibTeX records. If each item had a number, mm-hmm. a sort of a unique identifier, then you could say, here's the list of the unique identifiers that you will need. And here's a place where you can get them from. and you don't have to worry about inputting any files anywhere. You just have to say, here's a list of the numbers, and the list of the numbers will be generated from your system, because your system will say, these are the numbers of the records I'm using. That will become a bit clearer, I hope, when I do the demonstration. So in the demonstration, I have a list of famous first lines. It's a short list, but I show how we can extract from that list and do things with it. So I hope that's helpful. Shall I move on now? Okay, this was going to be a little bit funny. Right, so I'm using Python as my programming language. And is the font size satisfactory? I hope it is.
You're not sharing your screen.
Oh, I'm sorry.
You will be sorry.
That's an important area. Share window or screen. Come on. Entire screen. Here we go. Wow. Okay. Yep. Okay. So I can't see the meeting, so you'll have to speak to get my attention.
Okay.
So I'm not using command line Git. We're all used to Git help, and it gives you a long list of commands: rebase, merge, switch, tag, fetch, pull, all sorts of stuff. We're not using Git in that way, and we're not using a command line. We're using what's called pygit2. So pygit2 is a wrapper around something called libgit2, and libgit2 is the second version of a Linux Foundation library that exposes most of the core functionality that allows the command line interface to work. So it's not for building a command line interface, it's more for doing administrative things that you can't do with a command line interface. So let me explain what we're doing here. This first thing here is simply creating a temporary directory somewhere, which will get deleted when we're finished. And that's simply so I don't have these temporary directories cluttering my folder system up. So then we create the temporary directory, and then we're going to put we're going to create a Git repository here at the repo path, and we don't care what the repo path is because we're going to delete it anyway. And I'm going to list the repository, and we'll see what happens. Now, I'm not well set up for this. I could actually do this at the command line if it were helpful. So I'll just show you how it works. So here's Python 3. So this is So I'm just going to show you what temp is. That's a temporary directory somewhere on my in the current folder. I'll just write it here. So I've stored the dir name, and I'm going to import OS, and then repo equals Oh, sorry. This isn't the slickest of presentations, I'm afraid. So now I've created a repository. It's a repository at some strange location. And now I'm going to do something very interesting. I'm going to list everything in the repository. And there's nothing there, of course, because it's an empty repository. We just created it. Now, and you notice I've got the same number here as we've got there. So I've stored something in the repository. I've created a piece of data and put it in the repository. And now if we list the repository, we see it contains something. There's actually something called an object database inside the repository. And we can list the ODB and we get the same value as before. It sometimes helps to think of the object database rather than the repository. The repository holds the object database, but for what we're doing, the object database is the important thing. So if I just get hold of that number that I just showed you, and I now list and I can ask the ODB to read the high key, not the high Q, the high key. And that was the message we put in. And the number 3 at the beginning saying it's a blob, it's a piece of data rather than something else, such as a directory. We can also store directories. And we're now going to create a pack file. So the pack builder needs a repository from which it's going to get the stuff it's going to build. And then we're going to packer.add high key. So we've just added hello world to the pack that the packer is building. Here's another way we can add something. We'll skip that for the moment because it doesn't really help us very much. So now we're going to put in the by key. And having done with packing things, we'll ask for what we've packed to be written. So if we go over here and go to ls scratch, was it? Test script. Okay, so there's our odd repository, and it's got objects, and there might be a pack object here. No, I don't know. Where did we ask it to write it? Store.pack, that's better. Okay, so sorry, I asked it to write it into store pack. So there's our pack file that we just created. You notice the first entry there is the index file, which in our case is a bit big because it's got overhead. And the data we've got is just hello world and goodbye world. But what we can do is we can use the git command to verify the pack file, and we'll be verbose, and then we do store pack oh, for some reason I've only got one object here and I should have gotten two. Oh, that's because I didn't add it. I didn't do this. That's why I only got one object. So I'm going to pause for a moment. And are there any questions at this point? Shall I give a quick summary of what we've done? I've programmatically, inside Python, done things with Git. That's the first important thing. We can use Git without using the command line. We can just do it inside a program under our complete control. Even we don't have to we don't have to accept the way Git does things. We've got a lot of freedom ourselves to do things. The second thing is to talk about pack files. Pack files are usually quite large. The maximum size is 4 gigabytes, which is pretty big. And if you start packing and you overflow 4 gigabytes, Git is clever enough to say, okay, I'll close this pack file and I'll move on to the next one. So I'll just create a series of pack files. And the long number at the bottom of the pack file is an identifier. And any pack file that legitimately has that long number, which is computed from the contents of the pack file, if any pack file legitimately has that number, then it's the same. So just as this blob here is always holding hello world, so this is always the same pack file. So if we have TeX Live 2023 and part of it comes as a pack file, to get all that stuff, you download the pack file with this long identifier, and you're guaranteed to have exactly the same as somebody else. So one of the great things about a pack file is ensuring that two people have the same resources available. And if I make sure that everything I use comes from this pack file and this pack file, and I list the pack files I give, then I can say to the other person, make sure you get these pack files, and then you're set to go. Now I'm worried because I don't know if I'm understood.
Yep, I understand.
Okay. Is there a question at this point?
I have one, Jonathan. Now, supposing you were using this to do as you suggested, to share a collection of strings and files, doesn't the user at the other end who somehow downloaded these over the network now have to unpack them to recover those files?
No. I think that's probably the next thing I do. You can ask it to. Well, the first thing is, because it's a Git repository, you can say here, if one of the things you said is, if one of the things you send is a tree object, then Git will very happily write that tree out onto disk. So ordinary software can get hold of it. But if you want one particular file, you can ask Git to type it to the console, and then you can pipe it to wherever you want. So you should think of Git being a bit like a zip file. You can create a zip file programmatically without having any files on disk. and you can read a zip file programmatically without having to write anything onto disk, or you can do it onto disk if you want to. And the software is basically the same in both cases. The behavior is basically the same, but in one case the output is a stream, and in the other case the output is something on disk. Does that go some way to answering your question, Nelson?
Right. So this means then that the user at the other end doesn't need to know anything about Python. All they've done is a save from a URL you sent them, and then they have to run Git to unpack it into files that they can then use to typeset their document.
That's right, and I'm sorry I didn't make that clear, that I'm really speaking developer to developer rather than user to user. So I have in my mind a picture of what I want to build, and these are some of the tools that I want to use to build it. And as developers, I want to sort of communicate the idea that we shouldn't be thinking about files on disk so much as objects that are available. So we're quite comfortable reading a stream through a socket over the internet. And sometimes it behaves like a file because it's a network file system. So we can make such things behave like files if we want to, even though they're not actually files. What I'm concerned with, mainly in this session, is creating a pack file that is useful. A pack file typically will be about 1 gigabyte, and it should contain a whole bunch of stuff, 90% of which is not useful to the user, but the 10% that is worth having. So they'll download that gigabyte and they'll share it with everybody if they want to. And a large part of the data consists of blobs. And because the blobs don't have names, they just have numbers. And because the numbers determine the contents of the blobs, you don't have name collisions. So it's not a question of, I followed this path and I got the wrong resource. It's, I gave this number and I got the same resource. So that's a sort of underlying feature that Git provides. And on top of that, it can build other means of ensuring you get the same resources. Does that help you, Nelson?
Yeah, so I'm assuming then that the user who has got this pack file does a Git pull on it.
Yeah, effectively.
I'm thinking in the context of you're sharing a tree of documents, LaTeX files, bibliographies, images, and so on with your friend. They don't know anything about Python or Git, and you simply say, well, grab this URL, run this single Git command, and you will have everything on your machine that I have.
Yeah, now when you do a Git pull, it's quite interesting. When you do a Git pull, I think this is a model to follow. You usually, in fact, you only pull something that's tagged. So give me pull the latest release of the software I'm developing against. So, and what happens is that request is converted into a secure hash that represents a commit usually, and that commit has got a tree, and then your machine and the server negotiate about what needs to be sent down, and the Git server on the fly will create a pack file that gives you exactly what you're missing. And if 3 lines in a file are missing and you're missing those 3 changed lines, it will send a pack file that contains what's called a delta. So it says, well, I know he's got version 37 of this, but he needs version 38, and the difference is these lines. So I just send him that difference. So it's fantastically efficient on network resources. Right. It's a sort of high-level compression. Now, I'm not interested in version control here. I'm just interested in sharing objects, but the mechanism that Git develops for sharing objects is through pack files. So what happens when you do a pull is that the repository you're pulling from will send you a pack file, custom made for you, as being the most efficient way of securely communicating to you the additional files you need. But I'm trying to deal with all of that completely separate from the Git version control system. And you may have noticed that I started with an empty repository and I didn't do a single commit. but I managed to get a pack file out of it.
So let's pursue this now. So you're the group leader, the project leader, the Git master, and so on. Your colleague who's co-authoring the article you're jointly working on has now spent an afternoon updating it and wants to get you the changes. What do they have to do at their end so that
Now my
those
response to
differences can be uploaded to you?
My response to that would be, you're probably best off using Git version control for your to share your files, but you can do it. But you can do it directly if you want, and if you want to, you can zip up the whole lot and just send it. Just sort of. But regarding all the resources from TeX Live, my view is make sure you've got the right pack files inside your TeX Live store. So I wrote something into the store. Now we can have multiple stores, and we can have one of the stores that contains all the TeX Live stuff that we want. And when we have a new release of TeX Live or an update, we simply put more pack files into that store, and the underlying content of all the files that we need, of all the new files, is then added and made available. So if there's a new release of TeX Live and there's 50 or 100 new files, we can add those new files as blobs and put them into a pack file. And then if you put this is what we'll see later, if you put that pack file into the store, they become available. And everything else becomes available, and nothing has changed except the library has got a bit bigger, but all the old classics are still there and working exactly as before.
Good.
That will become clearer when I hope, when I go on and demonstrate a couple more things. Is that all right?
Yes, that's fine. Thanks.
Okay. So, sorry. So this is a little script which reads the objects in the store. So I'm creating an object database. This is the class, and then the little ODB is an instance of the class, and I make it look in our store, and then I print all the keys in the object database, and for every key in the object database, I'll print, I'll read the key and print it. Now, what I'll do here is I'll do it at the console, and we'll get a slightly different answer to what we scripted because of my error earlier. So this allows us to create an object database, which we will now do simply by calling the class. And sometimes we can pass parameters to the call, as we did when we set up the repository. And then for key in ODB, print key. And because we didn't put both of the objects in, and because we can't spell, well, that's very odd. What I'm going to do is I'm going to run the previous script again. Sorry about this. This might work now. Ah, I know what I want. I forgot that. I know what went wrong, by the way. I forgot this very important line here. This is the nice thing about doing demonstrations, is that it keeps you honest. So what I'm doing is I'm adding the store, which we recently put things there. So this is equivalent to creating a small Git repository and then saying, oh, by the way, if you can't find anything in your meager resources, go and have a look at the big store and try and get it from there. So it's a way of providing a backing store. It's a bit like a library has a stack with all sorts of books available that are rarely consulted. So if we do that, we'll now actually get 3 entries, 2 of which we wanted. Oh, we've got 2 copies of the same entry. That's interesting, isn't it? And both those entries will be the same, and we'll see that for key in ODB, print O. Okay, so we've got that same entry twice, because if we have a look in store pack, we see we've got 2 packs and 2 indexes where I was assuming we'd only have 1. And there's a certain duplication between the packs, and it does no harm because both of these hello worlds have the same key, have the same secure hash, and they must do if they have the same content. So I think pause for questions. Okay. Okay, now we're getting a bit more real world. So here I build an empty pack. That's the first thing I do, is build a pack with nothing in it. That was me testing that things work. But then here's the interesting stuff. First lines. It is a truth universally acknowledged that a single man in possession of good fortune must be in want of a wife. That's Jane Austen, of course. Now, this is a list of first lines. And then I do a bit of Python cleverness to normalize the white space. It's probably good sense to normalize the white space before you put it in the store, because the great thing about normalized content is it will have the same hash, whereas these extra white spaces here, which don't cause me any problem, cause a bit of problem here. So what we'll do here is we'll do much as before, and we'll write stuff into the pack. So let's just run this script, and there you've seen what's in the pack file. And if we do Python 3 script3.py, didn't take long, did it? You see we've got extra contents in the pack file. Now, if we do an ls-l, we can probably guess which one is which. It's the big one, which is probably this one here, because it's 609 bytes. So let's just do this one here. It's A42. dot pack. No, not that one. Six and nine. Did script 3. Oh, it's this. It's this one here. It's 029. One of the things that happens to people that use Git at the command line a bit is that they get very good at remembering initial. I don't understand what's going on here. I'm going to just move on to the next script and leave this as a puzzle for the moment. We can go back to it. What do we do here? Don't remember what we did here. So we start with a repository. We add an alternate class called the store. And then we create a pack file. I've no idea what we're doing here. I think what we're doing is creating a pack file that contains everything. Let's $7.26. So there's the pack file we just created. Okay, so we've created here a pack file that contains 7 objects. And I guess they're the 5 first lines and the hello world, and that's all, folks. So now what we're going to do is going to read everything in the store. So this is like the big backing store that's got all the stuff we want in it. And we're just going to read the data and write down the key in the first part of the data. So this is script 5. And there are a few repetitions here. Sorry, I'm going to go back to that one as well in a moment. There's a few repetitions here, but you see that we've got all the data that we put into it is available to us. And if I just go back to this one, the script 4, this was something of particular interest to me, and I now understand what it is that I'm doing. I'm taking the keys and sorting them. And I'm building the pack file with the keys in sort order. And if we look over at the bottom right screen, so the first entry here is 0. So do you see that these entries are in hexadecimal order? And because they're in hexadecimal order, it ensures that this key here depends only on the contents. Because if I pack the stuff in a different order, that key would change. So it's a way of normalizing the pack file in such a way that 2 pack files are the same in terms of the secure code if they have the same content. and that's sort of quite important if we want to determine that somebody's got the right pack files in their machines. If the pack file has got a different value and it meets this sorted criteria, then they are different. That's something that's important for me, but not so important for you. The thing that is important, it allows us, it shows that we have control over what we put in the store and how we put it into the store. So the pygit library, which in wrapper, which is around wraparound libgit, is sort of a bit like LuaTeX. LuaTeX allows you to program the internals of TeX using Lua. So this is, if you like, something that allows you to program the internals of Git using Python. It does it in a different way, but it has the same sort of goal. So let's start.py. I think I've come to the end of everything here. Yes, that's the end of my scripts because we did script 5. I'll just run it again. Script 5. This is the initial part of the secure hash, and then this is the initial part of the content, and we're getting some things twice because the same content is being stored in different places. And actually, if we look at this here, we can see that this is actually probably coming from here. I don't know. No, it's not. I can't figure this out.
Jonathan, if you were to just up arrow that Python 3 script 5 py command and pipe it into sort-u, that would reduce the line count because it would give you just the unique lines.
I'm certainly happy to do that.
Right, and so that's similar to what you did in your other script that had a sort operation applied to the keys before they were written.
Yeah.
That eliminated the duplicates.
Yeah. So if you're going to try and store each object only once, then you have to do sorting or something. The thing I was focused on, because it's something I'm sort of focused on, is getting all your ducks in a row, which is this thing here, right? So this came from this pack file down here. Do you see where I'm squiggling? This stuff came from here. And then this came from the pack file where they came in a different order, you see. If you remember the order of the first lines, these are in the order as given by the user, and this is by order of key. So these here, they're ordered by key, which means you can do a binary search on various things, but that's by and by. I think I should stop sharing soon. Are there any things people want to see from the sharing again or have questions about? I can always resume sharing if need be. Why don't I stop sharing and then we're much more face to face? So we'll stop sharing. So there's quite a lot going on here. I feel as though I've given a bit of a tutorial as well as a talk about goals. And I think it's appropriate to have done that. Carve, David. Oh,
Yeah.
sorry,
Yeah,
we've got a new person who's just arrived. Oh, hi, Ada.
Hi there. Hi.
Sorry, I didn't notice. I hope you weren't waiting for long. I didn't notice. I was full screen and I didn't see the that part of the window. I really need a second person here. This meeting is being recorded, and so you can catch up on it in a couple of days. I've got a feeling that David will have something to say.
Yeah, I had one question. I mean, earlier you said that you would include the files from Tech Live, right? That you thought you needed to actually compile the particular article. So how do you deal with the kind of the figuring this out? I mean, dealing with the dependencies.
Okay, so somebody's already written a bit of a tool for that, whose name I've forgotten. So Tech has a recorder option, it gives you a list of files. So you could take that list of files and just compute the hashes for them all, or the ones that come from the Tech Live tree. And that should work. And actually, if you computed those hashes, it will also tell you if the part of the tree that you've used has maintained its integrity. But if the whole tree were under Git version control, you could just say, what's the status of the tree? And I'll tell you, without having to program anything, whether or not it's changed. I started on this because I found that the distribution installation of Tech Live was slow. And there's an enormous amount of repetition year upon year upon year. And my initial experiment showed me that the difference from one year to the next is probably only a couple of gigabytes. And the other thing is the installation is on unpacking files that you never need. And if we just put them in the Git repository, then that deals with the transport mechanism. And you can unpack them on the fly if that's appropriate for you, or you can unpack them onto disk if that's appropriate for you. You can even put your popular stuff in a very quick disk right next to you. And it will look there first. And then if it doesn't find it, it'll go to the slower place. So part of it is about increasing the performance, and it's already quick and it needs to be quicker. The installation of Tech Live is slow. And here's a use case that came up, was I was involved with Brian Dunstan, I think his name, Brian, who is the developer of the very highly regarded LWarp, latex to HTML tool. And he and I and somebody else was doing all the work. Alex, don't remember the name, I'm afraid, were modifying it so that tables would have heading cells, so that the screen reader would say it's a genuine table rather than a piece of layout. And to test that stuff, you had to install the changes to LWarp in some suitable location, and you had to take your input file and see what happens. And that sort of ad hoc change is very, very difficult to do without using something like Git. And it doesn't have to be Git, but something like Git. And Git has a very nice, can't remember the exact name of it, but it's a binary command. So here, the software is good. Here, the software is bad. Bisect. So what happens is it downloads the version halfway between, runs the test, and then says, oh, it's still good, or it's already gone bad. And it narrows in, and then it will find this version is good, and this version is bad. And it will do it in logarithmic time, because that's the nature of binary search. So all those sorts of tools are built upon Git. And I'm just interested in, my first interest was making the management, so to speak, of TeX Live easier. But there are other things you can do with it once you've got that. So CTAN sort of uses rsync to move files from one place to the other. Well, there's no reason why it shouldn't simply say, here's the set of pack files I've got. Have you got exactly the same ones? Once you're in a situation where everybody's got exactly the same pack files, then it's a question of, well, do we have exactly the same trees? But the trees are relatively small compared to the pack files. I can't imagine the tree for TeX Live being more than a few megabytes, because all it is directory addresses and numbers. So those are the sorts of use cases I have in mind. And it might help if you had a particular use case that was important for you that you stated.
Oh, I'm just thinking in terms of archive, how this could be used.
Nelson here, I might interject a comment here. About a year ago on this hour, Jonathan and I made some experiments offline. LaTeX has the \list files command that gives you a list of files that are brought in. But my recollection is, and of course it's a year ago now, is that list omitted the fonts. It got all of the style files and so on, and your own input files, and that's fine. But the fonts are also part of the resources needed to typeset the document. And as recent traffic on the TeX Live list shows, people get into trouble when fonts that they think they're using are coming from possibly different sources and actually aren't the same. Fonts have a long history of being named, often with rather cryptic names, but without any version numbering. And publishers of fonts from time to time have tweaked them, changed the metrics, changed the character shapes, and so on. And they're re-released with exactly the same name as before. I have a sad case on my shelf of a book that was typeset by TeX, and the authors carefully made a nice book out of it. And it went to the publisher, who used a substitute font, and it changed a number of different characters in the mathematics throughout the book, effectively destroying the book. It was very unfortunate, but you can trace it back to the fact you really do need to have exactly the same files, including the fonts. And I don't know whether it's feasible for the LaTeX list files command to be extended to grab the files, because unfortunately, when you say \font in low-level TeX, you name a font handle that usually refers to a file in the file system. But when you're using CTeX or LuaTeX, you can use a long font name like Helvetica, Bold, Oblique, and it will use the system font search mechanism to find it. And I just don't know whether that's the final location and the real name of the font file is recordable.
I think it goes back, Nelson, to if you don't have identical inputs, you've got very little chance of getting identical outputs. And if that's important to you, if this reproducibility is important to you, then a tool that ensures that two systems have identical inputs is really valuable. And Git pack files reduce it to, do you have the same pack files in your master store?
Well,
Plus
I fully agree. The issue is that the dependencies that David mentioned, we really do need to know all of the files that are being pulled in. And if we can't currently list them with \list files, we have an issue.
I have ideas about fixing that issue, which are built upon using pack files. And basically the idea is this, that at some point you have a catalog that says, when this person says cmr10.tfm, this is what they mean. And what they mean is a particular secure hash. And you just have a dictionary for the external resource by name and the resource by number that corresponds to it. And so instead of opening a file by going down a path, you have a catalog that says, give me this exact object. Now, you can say specify it by path, but the path should be a means of specifying what the exact object is, or if it doesn't do that, it should at least tell you what the exact object is, because it should compute the secure hash as part of providing the object to you. So instead of directly making operating system calls to open a file in the TeX executable, you open them in a way that ensures that you get a secure hash and that that secure hash is recorded. So the file recorder, I think, works at the level of the kpath-c utility is told to record the files that it tries to find, but it doesn't at the same time record the secure hashes of those files, and it doesn't, as you say, record all the files.
The problem I see is that all modern operating systems are very keen on running updates regularly, so your system is up to date. And so if you rely on system resources, such as, say, a font installed in the system font directory, and that's been recently updated, fonts are often proprietary and licensed. And so your collaborator working on a different machine may not legally be able to pull the previous font that you had where you agreed on the checksums and the signatures. So certainly for things that are exclusively within the TeX tree, which by definition is freely distributable, we're perfectly fine, and this works great. But comments on the TeX Live list in the last few days indicate that people are relying heavily on system installed fonts. And it really worries me that vendors will change those fonts behind the scenes, update them. And now we're back in the situation where one user's updated, the other one hasn't. And the fonts are different and the document appearance is different because the metrics changed or a new character was added or something like that.
I think it ought to be possible to at least check that the same resources, that the resources being used are identical. Even if it's not
and we can, as long as we can find the names of the files, the font files in particular, that currently list files I don't believe records. This might be an easy problem to solve, but it might be more difficult. My concern is that for the ones that are using OTF fonts and TTF fonts, those are often looked up through a system font machinery, which is different across Windows, Mac OS, and Linux, and other Unix systems. And so there may not be any hooks to get in there to record where this file was finally found.
If you're in a situation where your software isn't reading the font, but rather your software is using the name of a font as a handle to get something done, then there is a big problem there.
Yeah, and that's exactly what happens with LuaTeX and CTEC. That you can use a path name, a font description name like Helvetica Bold Italic, and the font machinery looks it up, and all that the typesetting engine is doing is breaking the document into words, passing the word off to the font machinery and saying, please give me back a description of this with its width and height and depth and so on. And then I dump that into a file that says, this particular set of glyphs come from this particular font, but I may not have put that font into the say the PDF file.
Okay,
retrievable later.
For sort of legacy situations, there's a solution that involves containers. Something that's been introduced into Linux sort of recently in the last 10 or 15 years is user space file systems. So as long as you construct an object, I'll use that word vaguely, something that responds to requests, that has certain defined behaviors, then with the user space defined file system, it will look to the people that use it. You can mount a user-defined file system. You can define a file system where nothing exists in practice. It's all invented, if you like. And you could turn a Git tree into a user-defined file system without writing anything to disk. Whenever you try and open a file, behind the scenes, that object is expanded into memory, and file operations are done on that. Now, all this is being done, in one sense, behind the system call. It's the other side of the system call. So you make a system call, and then ordinarily you think, oh, I'll make a system call, and the system takes over. But with a user-defined file system, you make a system call, and it comes right back to the user. And the user can say, oh, they've asked to open that file. And the file system, user-defined file system, can act as a sort of interface or a buffer between the real file system and the application that's causing it. And so it can say, I've run this process in a container, and these are exactly the files it accessed in this folder. And these are the checksums of the files it accessed. And you can make the operating system do it by defining a user-defined file system that wraps the operating system, and then, so to speak, goes the other side of the system call. That's a bit like doing everything on a network file system, but then you packet sniff on the network file system, except you do it in a legal way.
It comes back to what we were talking about 2 weeks ago with the distro box capability of a simple interface to a container that you can guarantee will be identical. And probably for collaborative projects, that will be the preferred approach, because then you really can ensure that the same container is used at every site.
Yeah, that's all part of the puzzle. It's like none of these things by themselves will solve the problem of reproducible computing, but they can all act as contributions, and they can also all develop the culture. Would you like to speak, Adrian?
No, I was just waving goodbye to Cafe.
Yeah, sorry. Thank you very much, Jonathan. I gotta go. Thank you so much. See you next week.
Very well.
Bye. Thank you.
Nice to see you.
Thanks, Jonathan.
Oh, sorry, I missed your message, Carver. So, well, I'm sorry about things being a bit messed up at the beginning, and I'm also sorry that the demonstrations had a little bit too much of the live quality about them, if you like. But I'm very grateful to have been able to have this conversation, and I'm wanting to move this as early as is conveniently possible over to real-world problems. And I saw some of the work that Nelson has done on bibliographies, which is now on the TUG website. And I thought, well, what happens if we download that stuff and split it up into records and store it in blobs, just like the first lines of famous pieces of fiction and other things, and see how it works?
Yes, it's certainly doable. And in fact, in some sense, I do that in the many SQL databases that hold a form of these text files, that a large text file with thousands of entries ends up being thousands of database blobs that I can recall and search on.
Okay, so you've got an SQL database as a back end.
Yes, but it's not the master repository. The master files are always just plain text files that you can edit in a text editor and process with many different software tools. But what the SQL database offers you is the ability to say, I want all of the files whose author name is Knuth, written between 1983 and 1987.
Okay, so it allows you to query things. Yeah.
And it provides for very fast searching, usually of the much less than a second.
Oh, that would be interesting. Just to somebody told me that there's one of the laws of data normalization, which sort of creates redundancy, but that's quite slow if you want to search. So typically you denormalize a database so that you can do your queries quickly.
Yeah, the critical thing is that in order to achieve acceptable performance, you have to create indexes in the database. So I have indexes on the authors and the titles, the ISBNs, the journal names, and so on. And then it's easy to say, well, I'm only interested in articles from this specific journal. And that radically reduces the number of records the database engine has to look at. And it can achieve quite high performance. I'll send you offline some pointers to some documents that describe this.
Yeah, that would be good. I mean, I think I've done enough today to take one of your biggish files and split it up into pieces and put it into a pack file. And then I've got a pack file which has got thousands of incomprehensible numbers on it, and you've got to give those incomprehensible numbers meaningful names. But I assume that that's the BibTeX key that would do that for you.
Right. And what I've always made a point of doing in all of my bibliographic work is every BibTeX entry is a paragraph. That is, it's separated from others by at least one blank line. That makes it relatively trivial to extract the complete entry as a single object. Whereas if you're sloppy in your formatting, it can be much harder to parse things and pull them apart. But with consistently formatted BibTeX data, it's a relatively simple job, and it makes editing easy because you can concentrate on just a paragraph at a time. In fact, when I'm editing, doing complex edits on an entry, I often use the Emacs function that narrows the view to just the current paragraph. Then you know I can't possibly affect any of the other entries by say a replace string operation that replaces far more than I intended.
I suppose I want to backtrack a little bit and say that I see one of the key things in what I'm trying to do is to be able to take a file tree or something and say, here are all the blobs, just store those. And then a lot of your manipulations are related to file tree manipulations rather than blob manipulations. Maybe you have additional blobs coming in and you'll say, oh, take this tree and replace what you've got here at this blob by another thing. But I'm not interested in sort of doing developer style version control. I'm simply sort of, when you do a commit, you commit a tree. And I'm interested in having a list of useful and interesting tree roots. But I'm not interested in necessarily diffing or comparing them. So I'm interested in sort of giving each interesting tree root a name, but without looking at the history. Developers are often interested in the history, but if you're compiling, if you're using LaTeX to, if you're using the source files for LaTeX to compile to produce a PDF for you, you're not interested in the history and the previous versions of those files when you're doing the typesetting. All you're interested in is that specific tree and possibly only a very small part of that tree. So as a version control system, you sort of get all the previous versions whether you want them or not. And that's a problem in terms of being nimble in terms of cloud computing and all sorts of other things.
Exactly. Yeah, we can carry this on further by email. There's lots of nuances here that we probably shouldn't get into at this point late in the tech office hour.
I'd like once again to apologise for the technical snafus and for not being properly prepared to deal with them, but we've got there in the end. I'm very grateful for you all for staying on for a little while. I think if somebody wants to say something on the record, we're still being recorded, they're most welcome to, but otherwise I'll close, and if people want to stay and talk a bit longer, I'm also welcome to that. And next week, we have a special tech hour on innovation regarding tech in STEM, and we have Peter Williams, who's developed for Tectonic and keynote at the last TUG conference. Martin Ruckert, who is author of the hint system that provides a separation between the galley type setting and the pagination of tech. And that is motivated by a wish to have something, essentially to provide reflowable PDF. So when you change the screen size or you just use a different mobile device, you'd like the typography and everything to be the same, but you'd like the page makeup to be done for the size of the page you've actually got, rather than the size of the page that we're going to print to. And then the third person is Dennis Mueller, who is going to talk about semantic tech, which is part of the KWARC project, which is building a digital mathematical library. And his focus is on giving more semantic meaning to the mathematics of formal mathematics. So by formal mathematics, I mean anything that's published as a proof in a research journal. And if what are theorems could be better defined, then this will give better searching and all sorts of other features, much as Nelson wants to index his bibliography entries. So wouldn't it be nice if you could find the theorem you were looking for? Because the theorems have been sort of well written up. So that's the special tech hour next week, and it's for an hour, and then afterwards there'll be workshops or group discussion or whatever people want to take things further. So that's enough from me for now.
That sounds like fun. I think I'll check out now and head off to lunch.
Maybe if you think it's fun, you could invite other people.
Okay. We'll see you next week then.
Okay, thanks very much. Thanks, David.
Thank you.